Hello everyone, I am AMMAJI DUPPADA, and today in this session we are going to see orthogonal trajectories. It means how to find orthogonal trajectories of a given family of curves, or maybe a single curve. It is like, firstly you have to understand, like, it may be you may be given an equation, or you may be given with a family of curves. Like, the form is looking like this. It means you may be given you may be given with the you may be given with an equation, like, simply let us say x plus y is equal to some 10. It is like this. You may be given with an equation or a family of curves. A family of curves. It means that is the question, like, family of curves. The family of curves generally looks like a function having same, like x comma y comma constants is equal to 0. It means if they give you an equation or a family of curves, how to find orthogonal trajectories of that particular curves or of that particular family. Let us say, I simply give you one example here, a practical example. Let us say they have given a curve or equation like this. Now, what is the orthogonal trajectory? It means trajectory means it is a path. I have already explained in the beginning video also. Trajectory means a path taken by the curve or an equation. Now, you have to find orthogonal trajectory means you have to find another curve which is orthogonal to the given equation or given curve. Let us say which is this equation is cutting 90 degrees with respect to the original or given. It means this curve, let us say this is the curve 1, this is the curve 2. Now the angle at this point, the angle between them C1 and C2, angle between them is 90 degrees. It means you will be given with C1 equation or curve. You have to find the curve C2 which is cutting with 90 degrees with respect to the C1. That is what actually we call orthogonal trajectories. You will be given with a trajectory. You have to find a trajectory or an equation which is 90 degrees with respect to the given curve or given equation or given family of curves. So this is what actually the concept is. Now, what is the procedure we will see? The procedure is very simple, having 3 steps. So the first step is, firstly, step 1. The question is like you will be given with an equation. Question is like you will be given with an equation f of x comma y comma c is equal to 0. It means you will be given a family of curves having x terms, y terms, and c arbitrary constant terms. In the first step, what you have to do is you have to form a differential equation. You have to form a differential equation in the form of, let us say, like this: f of a family of curves, let us say small f, x comma y comma dy by dx is equal to 0. It means your equation should have x terms, y terms, and dy by dx terms only. It means c term, whatever the c term in the given equation or given family of curves, you have to eliminate. That is what actually we have read in the formation of differential equation. In the formation of differential equation video, in the previous video, we have eliminated that arbitrary constant and we have seen how to eliminate that also. So in this step, you have to eliminate C. You have to eliminate C in the given family of curves, that is called arbitrary constant, and you have to form an equation like this. In the step 2, you have to replace dy by dx term with the minus dx over dy, because see, one condition, that is m1 m2 is equal to -1 between the two curves in order to make them perpendicular. Let us say the curve m1, the curve 1 have slope m1, nothing but dy by dx. let us say curve 2 having slope m2, that is equal to minus dx by dy, let us say. See, now if you see, one condition will be satisfied, that is called product of the slopes is equal to -1. It is telling indirectly C2 is perpendicular to the C1 curve. That is what actually, that's why we are replacing dy over dx with the minus dx over dy. So this condition should be satisfied in order to make two curves perpendicular. So now, third step. In the third step, you have to finally, you obtained an equation, right? In the step 2, you get an equation like some function. What equation you will get? In this equation, x also will be there, y will be there. In the place of dy by dx, you are replacing with the minus dx over dy. You will get one equation only, but after replacing dy by dx with the minus dx over dy. Now you have to solve the obtained equation in the step 2, that is the step 3. Solve the obtained equation in step 2. That's it. This is the procedure behind orthogonal trajectories. Very simple, and I tell you, you will be given with a family of curves or a curve. You have to find orthogonal trajectory. Orthogonal trajectory means a trajectory or path or a curve or a family of curves that is perpendicular to the given curve or given equation or given family of curves. So this is what actually we are going to find out. These are the 3 steps you have to follow. Now straight away we will see one example. Let us solve an example. See, I told you, you will be given with a family of curves. Here one family of curves they have given, a family of confocal conics. The name of this family of curves is confocal conics. See, what is confocal conics? These are all things not necessary to understand as of now, as you are doing mathematics. The curve is looking like this: x square over a square plus y square over b square plus lambda is equal to 1. This is what actually they have given in equation, and they are mentioning like lambda is a parameter. It means lambda is a arbitrary constant. Now you have to identify the family of curves, or you have to find the family of curves which is perpendicular to the given curves. Perpendicular to the given curves. Now step 1 I am doing. What is the step 1? You have to form a differential equation. You have to form a differential equation, and by removing lambda, actually by removing lambda, because lambda is, by removing lambda is an arbitrary constant. So how to remove? It means how to form a differential equation. You have to operate the given equation with the differential coefficient. It means d by dx. So with respect to d by dx, you differentiate the whole equation. You differentiate. Then what you will get? The first term is 1 by a square is constant. 2x differentiation is, sorry, x square differentiation is 2x plus 1 over b square plus lambda is constant. Y square differentiation is 2y, but y is dependent variable, so dy over dx is equal to 0, because constant differentiation is 0. Now what you have to do is, so this you take that side, first term, or try to make an equation, like, you have to form a differential equation, right? Anyhow, the equation is formed. So now 1 over b square plus lambda into 2y into dy over dx is equal to minus 2x over a square. See, 2 will cancel. So you are getting an equation here, right? You are getting an equation in terms of dy by dx only. So if any cancellation terms are there, that you can cancel here itself. But here you have to check one line is called see, b square plus lambda you have to remove, right? So what I am doing is here, both sides I am multiplying with y. 2 will be cancelled anyhow. So if you multiply with y both sides, y square over b square plus lambda into dy over dx is equal to minus xy over a square. Why I have multiplied with y means, see, I have to remove this lambda. That is my main step, main task that I am doing in step 1. To remove lambda, see, I got now y square by b square plus lambda term. See, from the given equation I can write like y square by b square plus lambda is equal to 1 minus x square by a square. It means this term I can easily remove. So what I am doing now is, from the given question, y square by b square plus lambda, I can write, see, in this, from the given question, from the question, you can say y square by b square plus lambda is equal to 1 minus x square over a square. See, now this step I am writing y square by b square plus lambda is equal to 1 minus x square over a square into dy over dx is equal to minus xy over a square. Now this equation still you can solve. A square minus x square over a square into dy over dx is equal to minus xy over a square. Any cancellation terms are there? A square term is cancelled. Now equation is looking like dy over dx is equal to minus xy over a square minus x square. See, now the equation is having x terms, y terms, and dy by dx terms only. Now you can go for second step. What is the second step? You have to replace dy by dx with the minus dx over dy. Step 2, because you are going to find out orthogonal trajectory of the given curve. So you have to replace m1 with the minus 1 by m1. So put dy by dx is equal to minus dx over dy. So the equation become minus dx over dy is equal to minus xy over a square minus x square. Now, so far it is okay, good. So minus minus will be cancelled. So a square minus x square terms you bring this side. A square minus x square into dx is equal to xy dy. Now this equation also can, x you can bring this side. It means actually I am simply, what I am doing is x terms I am taking one side and y terms I am taking another side. That is what actually I am doing. So a square minus x square over x dx is equal to y dy. Now see, this equation I can simply solve. In step 3, what I have to do? I have to solve the differential equation, which is having dx minus dx dy term, x and y terms. So step 3, solve the differential equation. See, in order to solve a differential equation, what we have to do? Already the equation I brought, like I separated x and dx terms and y and dy terms. Now simply I can apply variable separable method. So I am applying integration. Apply integration on both sides. So now integration of a square minus x square over x dx is equal to integration of y dy. So integration of a square by x. A square is constant, 1 by x term is log x. Minus integration of x square by x, nothing but x only. It means x square over 2 is equal to integration of y dy, y square by 2 plus some that arbitrary constant every time you have to add, I said. So plus c. Now you can simply write this equation like a square log x is equal to this term, you take it that side, x square by 2 plus y square by 2 plus constant. So still if you can 2 you can take common in the LCM, you can take in the right hand side. So 2a square log x is equal to x square plus y square plus 2c. 2c also is another arbitrary constant only. So I am taking c dash. So this is what a curve which is perpendicular to the given family of curves. See here, family of curves means one thing only. I repeat with practical example. Let us say now the given family of curves is this. Family of curves means actually it's like flux. See, this is one type of, this is the question they have given, let us say, a family of curves. Now my answer is, this is the answer, right? We got finally. My answer also curve only, family of curves only. That family of curves are like this, which are exactly cutting or crossing the given family of curves with the 90 degrees. With the 90 degrees. That is what is my answer. So this is how you need to find orthogonal trajectories. Here the name itself, it is telling like ortho means 90 degrees. Trajectory means path. You will be, so from the beginning, let us have a little summarization. So the question is like this, a confocal conics family of curves they have given. This is the question. Lambda is the parameter. In the step 1, what we have done is we formed a differential equation. We just formed a differential equation by eliminating a parameter called arbitrary constant, that is lambda. In the second term, in the second step, what we have done is we have replaced dy by dx term with the minus dx over dy term, because m1 dy by dx is slope m1, minus dx by dy is the slope another m2. m1 into m2 should be is equal to minus 1 in order to make them perpendicular. So I replaced it. After replacing it, in the third step, what I have done is I applied integration on both sides, because I have to solve the differential equation again in order to make an equation. So this is actually variable separable method. That is what we have covered in first method. In many methods that we have so far seen in the videos like. So this is the way you need to solve or find orthogonal trajectories. Thank you all for watching this video.